Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, and in this session we are going to find out the Laplace transform of the delta function, that is delta of x square minus 3x plus 2. That is the Laplace transform of this function, right? And here we can see that x square minus 3x plus 2 is a quadratic polynomial. Now let us first see the definition of Laplace transform of a function, say f of x. And the Laplace transform of the function f of x is defined by the integral, that is 0 to infinity, and here we have e raised to minus sx, and we have the function f of x dx, right? And here f of x is given by the delta function, that is delta of x square minus 3x plus 2. So the Laplace transform of this function is given by the integral, that is 0 to infinity, and we have e raised to minus sx, and here we have delta of x square minus 3x plus 2 dx. So now let us evaluate this integral by using the property of Dirac delta function. So now we can write this quadratic function as a product of two linear factors. So let us factorize this quadratic polynomial by splitting the middle term. So we have x square minus 2x minus x plus 2, and then we can take these two terms and these two terms. We have x minus 2, and here we have x minus 2. So this is x minus 2 and x minus 1. So now this integral can be written as 0 to infinity, and then we have delta of x minus 2 and x minus 1, right? And to evaluate this integral, let us make use of one important property of Dirac delta function, which says that if we have delta of say x minus a, x minus b, that is the product of two linear factors x minus a and x minus b, then this expression is equal to 1 over absolute value of a minus b, and then we have delta of x minus a plus delta of x minus b. So now comparing this delta function with this one, we can see that the value of a can be taken as 2, and the value of b can be taken as 1. So here we have 1 over mod of 2 minus 1, and here we have delta of x minus 2 plus delta of x minus 1, and mod of 2 minus 1 is mod of 1, that is equal to 1. So this quantity is equal to 1. So we have here a delta of x minus 2 plus delta of x minus 1. So let us substitute the value of this expression, that is this one, in this integral. So we have now 0 to infinity, and then we can write here delta of x minus 2 plus delta of x minus 1, and here we have dx. So let us write this integral as a sum of two integrals. So we have 0 to infinity, then we have e raised to sx delta of x minus 2 dx plus 0 to infinity e raised to minus sx and delta of x minus 1 dx. So now we have two integrals. So now to get the values of these two integrals, we have to make use of this definition of Dirac delta function, that is integral minus infinity to infinity. And if we have a function say f of x and delta of x minus a dx, then the value of this integral is given by the value of this function at this point, right? So we have here f of a. So now if we compare this integral with this one, then this is our function f of x, right? And here the limits are from minus infinity to infinity, but here the limits are from 0 to infinity. The only important thing is that this point, that is 2, that is x is equal to 2, it lies in the domain that is 0 to infinity, right? And similar is the case with this integral. So here 1, that is x is equal to 1, it lies within this interval that is 0 to infinity. So here f of x is e raised to minus sx, and the value of a is given by 2, right? So the value of this integral is given by e raised to minus x times s, and this is to be evaluated at this point, that is x is equal to 2. And similar is the case with this one. Here the value of a is 2, and f of x is given by this function. So the value of this integral is given by the value of this expression at x is equal to 1. So now here we have e raised to minus s times 2 because x is equal to 2, and here we have minus s times 1 because x is equal to 1, right? So we can now write e raised to minus s plus e raised to minus 2s. So the Laplace transform of delta of x square minus 3x plus 2 is given by this expression e raised to minus s plus e raised to minus 2s.